Welcome to another Intermediate Algebra video. In this video, we'll start to look at graphing quadratics. Our objectives for this video are to graph quadratics of the form, and then we have 5 different forms. So we're going to look at x squared plus k. That k could be positive or negative. The second one is kind of a version of x squared. So instead of x squared, we have something added or subtracted to that x inside the parentheses. The third version is seeing both of those manipulations happen at once. The fourth version is if we multiply something by the x squared, so a number, positive, negative, being multiplied by the x squared. And the last version is the ultimate goal, which is the compilation of all 3 of those modifications. So we're going to look at what a number added subtracted to the end does, a number added or subtracted inside the parentheses, and then a number multiplying by the quantity. And we'll see all of those things happening at once on this final objective. So ultimate goal is the final objective. We're going to go through piece by piece to see what each thing does to get us to that final objective. Okay, so our notes. Our notes are really where we're going to come up with what these modifications are. So again, our ultimate goal is to be able to graph quadratics of this form, a times the quantity x minus h squared plus k. So let's first get an idea of what the parent function looks like. This right here, this is your standard x squared. We want to know what just that basic graph looks like. This one is called the parent function. Okay, so let's draw a little graph over here for ourselves. And then let's plug some points in. You could put it in the calculator, but I want to do this first one by hand. The rest I'm going to have you do in the calculator, but let's get an idea of the general picture by hand to begin with. So let's say we plug in a few numbers for x into this function. Let's say we plug in 0. We have 0 squared is 0, so there's one ordered pair. Let's say we plug in 1. 1 squared is 1, so the outcome would be 1. Let's say we plug in 2. We're plugging in 2 to be squared here, which gives us 4. And then just to compare, let's do a couple numbers in the negatives. I know without any sort of intro, it's hard to know what numbers would be important to pick, which is why we're doing this first one by hand. But after this, you can kind of get an idea of what would be a good choice. So let's go with -1. We'll adjust on the other side. If we plug -1 in, we have -1, quantity squared is -1 times -1, which is positive 1. And then let's also go with -2 plugging in. -2, quantity squared means -2 times -2, which is positive 4. So we have a good list of ordered pairs. Let's go ahead and plot those. Yeah, let's draw some tick marks for ourselves. Let's go with red. All right, so let's plot these ordered pairs. We have 0, 0. We have 1, 1. We have 2, 4, -1, 1, and -2, 4. And these will connect to form our graph. So you can pull them together. And I know it's difficult to tell. If you look at it on the calculator, you'll be able to see very clearly that what's happening here at the bottom is a U shape. I know it's, how would you know if it's a U or a V? Look at the calculator. If you plugged in some points closer, you would see that the shape created is a U. But this is a standard parabola. Your parent function of a quadratic looks just like this. And everything we're looking at will be a parabola. It follows this general shape. Maybe there's a shift, stretch, compress, something like that. Some sort of modification to it, but it's that general shape that will exist. Okay, so this is our parent function. Now we're going to look at, okay, what if we make some changes? What if we have a number at the end that's positive? What if we have a number at the end that's negative? What if we have a number in this parentheses, positive or negative? And then what if we make a change to this a value? We're going to look at each one individually. All right, so let's come up with a little example. Let's say, for example, for this first one, we want our k value to be positive, and that's the only modification we're going to make. Actually, before we look at that, let's identify what the standard a, h, and k values are on the parent function. A, h, and k. This is good to know what the standards are so we know how they can change. Okay, so our a value, this is a number multiplying by the quantity x squared. What's our standard value? If we don't see a number multiplying on the outside here, then the implication is that it's a 1. We'll draw it like this. Our standard is 1. How about our h value? What number is being added or subtracted inside parentheses to the x? If we don't see 1 and nothing exists there, then there's a 0 being added or subtracted. And the same goes for the last piece. What number do we have added or subtracted onto the end? It's nothing, so our k value is also a 0. You could look at this if you want to see it in the same format as the ultimate objective here is to write 1 times the quantity x minus 0 squared plus 0. These two are equivalent. You don't have to write it this way, but this helps you kind of see exactly what it could look like. All right, so let's say the only modification we want to make from this standard is that we have a positive k value. That could be something like x squared plus 2, right? This is a k value. It's a number added on at the end, and it's positive, so it's a plus positive 2. What could our negative look like? This would be f of x equals x squared, and then we still want plus, but it's a negative number, so ultimately it'll say minus. Pick any number you want to. I'm going to go with pretty small numbers so you can see them on your calculator, or when you draw the picture you'll be able to see it pretty easily. So let's just go with 3. All right, so let's see what kind of modification this makes. I think I'm going to have to erase this little general one so we can fit in the note of what will happen there. Okay, so go ahead and type each of these into your calculator. First thing I want you to do is type in the parent function. We're going to keep that one as your standard. So remember, on your calculator, you're going to go to the y equals screen. It's at the top left of your calculator, however you need to get in there. On the first y equals, we'll go with x squared, and on the second one, in this case, we're going to go with x squared plus 2. And we want to compare those graphs. What happens? So let's type it in. And x squared plus 2. So when you look at your graph, first you'll see our standard parent function graph, this one right here. And what does the second one look like? How would you describe that modification? It went up 2 units. Hopefully that's what you're seeing. This one goes up 2. So what do you think a positive k value causes the graph to do in general terms? It causes it to go up. We'll write that in red, up. Okay, to compare, now go ahead and keep that y equals x squared on your first line, and then type in the x squared minus 3 in the second line and compare the graphs. Back on our screen, we'll type in x squared minus 3, and when you go back to the graph, it again will first draw your standard parent graph, and then it will draw your x squared minus 3 graph. I'll give you a quick sketch of that one. I won't have enough room to keep it, just so you know. So this is your standard. It should touch at the bottom there. And then the new graph looks something like this. It actually probably comes up a little faster. But in general, you can see the modification is that the new graph is moved down 3 units. So if we have the standard parent function and we notice there's a number being subtracted or a negative number at the very end of your function, that will cause a downward movement. So the modification here would be down. And that makes sense. If positive causes you to go up, negative would cause you to go down. Okay, Now let's individually identify what would happen for an h value. So again, the standard parent function is your x squared. Uh-oh, there we go. Not red. Okay, so let's say, for example, instead of there being a 0 subtracted inside the parentheses, we're going to have a positive number subtracted. So let's say our h value is a 4. This is a tricky one because the formula itself says x minus h, and it has to say it this way, x minus h. The h value we're plugging in is a positive 4, so now it reads subtraction. Okay, to compare, let's go ahead and type in, or use a minus. Let's say we want to do -2. You could pick any number, it doesn't matter. But if we say that h is going to be a negative number, it'll read x minus the quantity, or just x minus -2, which will ultimately read x plus 2 squared. So when h is a negative number, inside the parentheses we'll say positive. When it's a positive number, it'll read negative, and that's because this is the base of the formula. This is where you're always modifying from. Okay, so take a guess. What do you think will happen in this modification? If the k value caused us to go up and down, what do you think h will have a change for? If you're not sure, go ahead and type them into the calculator. So let's still compare to this parent function. We have y equals x squared. Let's go ahead and compare that to the first one, x minus 4 quantity squared. So you're typing this into the calculator. The first one we already have in there. The second one, don't forget it has to read with the parentheses like that. We have x minus 4 quantity squared. And then when we look at the graph, we have our parent function and our new graph drawn in which direction? To the right. Let's add that as a note here. This causes it to move right. So a positive h value causes the graph to move to the right. I'll give you a quick sketch of what this looks like. We have our parent, which looks something like this. And then our new graph is 1, 2, 3, 4 units moved to the right. The exact same picture picked up and moved over. Okay, so if a positive causes it to move to the right, what do you think the negative is going to cause it to do? To the left. You can type it into the calculator to verify it for yourself, but this is definitely correct. If you type in, you can type in either one, minus -2 or x plus 2 quantity squared. You'll get the same result. This one causes the graph to move to the left. Now, this chart has a lot of information, and we're not quite done with it yet. But the good news is, if you don't remember what these are, because one thing you can do if you want to is memorize a positive k up, negative k down, positive h right, negative h left. Or you can just plug them into your calculator just like we're doing now to see what those modifications are and then be able to describe what would happen. Okay, the last type of modification we're going to look for is a change to this standard a value. And there's a few different ways we can look at it. Okay, we could say we want our a value to be a positive number less than 1, that's what the absolute value tells you, or a positive number greater than 1. We have all these changes. If we're on the positive side, it could be that it's between 0 and 1, or it could be that it's greater than 1, or it could be that it's a negative, and these will all three have different modifications. So let's come up with an example to type in for each of these. So now the only thing we're going to change is our a value, and we want it to be a positive number less than 1. So let's say we go with 1/2 or 0.5. They're the same thing. I'll type in the decimal. Now we're looking at this modification independently. Eventually they'll all happen together, and we'll have to say there's a this k which causes this, there's a this h which causes this, there's a this a which causes this. All right, so let's say we have this as an example here. Let's go with an a value positive a value greater than 1 to be 3. You can pick whatever you want to. We're just looking for the general type of modification. And then let's type those in. At this point, obviously, it can't be a simple left, right, up, down. Something else has to happen. So let's go ahead and type in the 0.5. Whoops, we want this one. 0.5x squared. No parentheses there because that number is on the outside. So back on your y equals screen, you still have y equals x squared typed in. Now we're going to type in 0.5x squared for our second graph. 0.5x squared. And then look at the graph. I'll do a quick sketch here. If this is our parent, this is the parent. In every case, we're describing what happens to this basic function. What difference do you see? What happened to the graph? It's on the outside of it, right? That's one way to describe it. The standard way that we will describe this is that it's wider. There's a lot of different ways you could make this description. You could say that it's vertically compressed. You could say it's horizontally stretched. You'll see more of this kind of thing in college algebra as you move forward. This will be the basic same thing for all of your graphs. But we're gonna keep it simple, and we are going to say that this graph is wider. We'll go on an in and out description. So the ultimate, if the number was a positive and less than 1, is that the graph got wider. So we had our original, and then the new one kind of stretched out and was wider. All right, so what do you think will happen if we have a positive greater than 1? Your guess would probably be correct. It's going to be the opposite of it going wider. It'll be narrower. So let's plug it in and make sure. Go ahead and type that into your calculator to be able to see. We have our standard graph and then the new graph right inside of it. I'll give you a quick sketch of that one. Here's our standard. And then the modified graph. It's the same shape. The modification is that it's inside of it. It's a narrower graph. Think of taking it and you're pulling it either this way or this way. You're stretching it out, making it wider, or pushing it in, making it narrower. And that'll be the description that we use. Now, the truth is it's narrower by a factor of whatever number exists here. That's not something I want you to be too concerned with quite now in college algebra. That's something you'll see more of is making those descriptions. But the number plays a role in how much wider or how much narrower the graph is. Wider, narrower. And then there's one last modification. And this is an important one. So if our a value is positive less than 1, positive greater than 1, a negative number happens independent of these two. So when you look at an a value, you have to assess, is it a less than 1 or greater than 1 number, and then is it negative? So think of that as two separate considerations. So for a negative, let's say our example is, let's go with just a negative happening to the parent. So let's say negative, our standard is 1, so we'll keep it 1, x squared. Take a guess. What do you think will happen? And then go ahead and plug it into the calculator. So in this case, we're plugging in negative x squared. And then let's see what the new graph looks like. Graph. Remember that the calculator reads negative and minus as different things. So if you type in minus x squared, it might say error. You need to make sure you're using the negative key to type it in here. Oh, good. All right, so here is our standard. And then what does the new graph look like? The new graph is flipped upside down. That's one way to describe it. You could use a few different descriptions, but the one we're going to use is a reflection. And what is it being reflected over? Remember, this line is our x-axis, so it's an x-axis reflection. Take that out. This causes an x-axis reflection. Okay, so we have a note for each of the variables independently that takes care of the first, second, and I suppose the fourth objective on the previous slide. What we're going to do next is now pull all of those together. We know what the general modifications are for them individually. Now we're going to have a problem that has an a, h, and k value, and we're going to list all the modifications. All of these can happen at the same time. Well, I guess not up, down, right, left. It could go up or down. It could go right or left. It could be narrow or wider, and there could be an x-axis reflection. Potentially 4 modifications can happen to this parent function. That's the one we're always going off of. What happens to that parent function? It gets shifted here, reflected here, and it's wider. That's kind of how we'll describe these on the next page. I think that's good here. All right. Okay, so now let's take a look at some practice problems. Okay, our examples we're going to do together. The question, what modifications happen to the parent graph, f of x equals x squared, just like we previously saw. And then we're also going to label the vertex and the axis of symmetry. We didn't talk about that on the last slide, but both of those things are a pretty easy find. So, whoops. Here we go. We want this white. Okay, so we want the vertex and the axis of symmetry. So on the previous slide, we were talking about the letters A, H, and K. The vertex, very simply, is that base point of your U shape, of your parabola, and that base point is always the h, k value. So not only is it important to identify h and k to be able to tell which modifications left, right, up, and down happen, but it also identifies for you the vertex, the base point of the U, whether that shape is opening up or opening down, the vertex will be the same. And then your axis of symmetry is it's a line where the graph would be able to fold upon itself. So if you folded over that dotted line, we'll typically draw it as a dotted line, the line would appear over itself. So you can imagine in this U shape, when we fold it on top of itself, we'll have just one half of it. The axis of symmetry, like I said, it's always the equation of a line. And since it's always a vertical line, it's always an x equals equation, at least on our standard parabolas. You don't have to worry about anything different in this course. And it's always x equals the h value. The h is the x coordinate of your vertex, and that's where it would fold over on top of itself, is the equation of that line. So when we identify a, h, and k, we'll be able to identify vertex and axis of symmetry. Okay, so let's identify those on our 2 examples here. On our first problem, f of x equals x minus 1 quantity squared minus 5. We have an h value. Identify them in whatever order you want to. We have an h value of 1, a k value of negative 5, and an a value of 1. A value of 1 means there are no modifications. So while it's helpful to identify it, it doesn't lead to anything. An h value of 1 causes what kind of modification? It's a positive, which causes it to move to the right. So, right, 1 unit. And a k value of negative 5, remember negative causes a down movement, causes it to move down a total of 5 units. So from the standard graph, the picture is picked up and moved to the right 1 unit and then down 5 units. And those are the only modifications that happen. Okay, then we're also going to label the vertex. The vertex is the h, k value. It's an ordered pair. It's a point. So in this case, it would be 1, negative 5. And the axis of symmetry, which will often be shortened AOS, axis of symmetry. Remember, it's the equation of a line, x equals, and our h value is 1. So let me show you what this would look like. Quickly, we have our standard graph. Then the new graph is moved to the right, and then down. Imagine that whole thing being picked up, right? This base point being picked up and moved over and down 5, so the same shape exists. The vertex is at 1, negative 5, just like you can see. That's exactly the movement that happened. And then your axis of symmetry, when we refer to x equals 1, we're referring to this line. this dotted line where the graph would clearly fold over on top of itself. So you don't have to draw the picture in every case. Sometimes you'll be asked to. But for this question, for these two problems, we're being asked to identify the moves, the vertex, and the axis of symmetry. It's very popular to identify those things. Okay, for the second one, let's identify our A, H, and K, and then tell what kind of translations those mean, and then what our vertex and axis of symmetry would be. So in this case, we have an H value of -3. Remember, the base form is A times X minus H, quantity squared plus K. So in order for it to be minus, you could rewrite this as minus -3. That's how we get -3. Essentially, it's just always the opposite of the sign you see for H. Our K value is 0, which means there's no change there. The standard K value is 0. And the A value is -2. So then we'll say what kind of modifications these cause. Your H value being -3 causes it to move to the left 3 units. And your A value of -2 causes 2 changes. Remember, there's 2 potential changes with the A value. So the negative causes 1 change. The negative causes the x-axis reflection. X-axis reflection. And the 2 itself is a positive, a number greater than 1. We look at the absolute value of it, so it's a number greater than 1. And this causes the graph to be narrower. So we have 3 modifications: left 3 units, x-axis reflection, and narrower. Then we identify, and let's circle these, because when it says what modifications, this is what we're looking for, this list. You don't necessarily have to have labeled what A, H, and K were, but it really helps to be able to answer the questions. Then we'll label the vertex. The vertex is our H, K. Our H is -3, and our K value is 0. It's still part of the picture with your vertex. It just means the picture from this picture was picked up and moved to the left 3 units. So the base of the U shape is still at 0 for a Y value. So it has to be written in there. And then your axis of symmetry, it's always x equals, and in this case, it's -3. The graph was moved over 3 units. So the line with which the graph could fold on top of itself also moves over and is x equals -3. All right. Okay, so same type of questions. Go ahead and practice these on your own. Pause the video and we'll go through them together in a moment. Okay, so the first one, remember we're answering the same questions. Let's identify our A, H, and K value. Our H value in this case, it says x minus 4, so what does that make our H value? Makes it a positive 4. Our K value is -16, and our A value is 1/2. These are all different from the standard A, H, and K value, so let's list what these cause. The H value of 4 causes the graph to move to the right 4 units. K, -16 causes it to move down 16 units. And the A value of 1/2 causes the graph to be wider. Now, in a lot of cases, you can plug this into your calculator and look at the graph, and you'll probably pretty easily be able to see, here's the shift this way, this way, this way. But in this case, because it's moved down so many units, down 16 units, it's probably, for the most part, outside of your window. Now, you can always manipulate the window on the graph to be able to see things more accurately, but it's probably difficult to then count what's happening. That's why, as a general rule of thumb, it's best to just go from the equation. The graph can be of assistance, but you don't want that to be the only thing that you're using. So there are the modifications. Let's circle these. These would be the modifications. And then our vertex, always H, K. It's an ordered pair, so in this case 4, -16. It's that base point. It's important to be able to identify that. You'll see a lot more work like this in college algebra. And then your axis of symmetry, x equals that h value, which is 4. Okay, the second one. This one looks a little different, but it's the exact same type of thing. It's just that it's written in a different order. The way we're used to seeing the standard is ax minus h squared plus k. The only difference with this problem and the way it's presented is that the two pieces are flipped. You're seeing the a and then the h, the k being in the front. So the first thing I'm going to do is write them in the order we're used to seeing them so that we can very clearly associate the signs with each piece. Okay, so our h value. Remember, we need it to say minus h. If it says plus, that's the same as writing minus -1. So our h value is -1. Our k value is 4. And our a value is -3. So the h being a -1 causes the graph to move to the left 1 unit. Negative causes it to go to the left, just like we saw in the previous, when we took the notes. Our k value, +4, causes it to go up 4 units. So from the base, it goes left and then up 4 units. And our a value being -3 causes 2 changes. Causes an x-axis reflection. That's what the negative causes. And then the 3, and maybe I'll underline in colors, the negative causes the x-axis reflection. And the 3 itself causes the graph to be narrower. It's a tricky piece because you have to look at it as 2 separate things. Even though it's one piece of the picture, it's A. It tells you 2 different kinds of modifications. And then finally, our last 2 pieces here are the vertex. Always h comma k, so it's -1, 4. That's the base point of this graph. Now, in this case, it's flipped, but that's okay. It's still a very important piece. It's where the change happens from either down to up or up to down. And then your axis of symmetry, x equals, always your h value, -1. This is the equation of the line where the graph would fold on top of itself. All right, so in this video, we identified what a, h, and k caused to happen as a modification to the parent function, f of x equals x squared. And then we used that information to tell what modifications would happen, along with identifying vertex and axis of symmetry. I'll see you soon for another video.